From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Don Felker.
And I'm Kaushik Gopal.
Welcome to the show.
If you work on an Android app, and if you're listening to this podcast, I'm going to presume you do, you'll know that when your user reports a problem or a crash, it's the absolute worst feeling. To make matters worse, they might one-star your app, go on Twitter and complain about the app, and if they're feeling particularly merciless, probably go on Reddit or something and post it there. But you know what? They have absolutely every reason to. If you treat your customers basically as an offsite QA team, it's rude to them and it's just bad for business. As developers, we don't want to rely on customers to report errors. Instead, we want to catch this much early on. Ideally, you just have automated tests and these tell you when there's a problem. But, as we've talked about on the show multiple times, that's not always as easy as we want it to be. Because writing tests can be hard. That's why Sentry, our sponsor for today's show, tells you about errors in your code before your customers have a chance to encounter them. Not only do they tell you about the errors, they also give you helpful details that help you fix these errors. For example, how many users were impacted by this bug, the complete stack trace if it's a crash, the commit ID when this error was released, the engineer who wrote this line of code that was busted, that and a whole lot more. If your code is broken, let's fix it together. That's Sentry's tagline. I love it. You can check them out at sentry.io/for/Android. Sentry is a pretty common word. It's actually a pretty cool name for the service if you know the English meaning of the word. But I want to make sure you get that domain name right. It's sentry.io. Once again, sentry.io/for, as in FOR/Android. Check them out today and fix your errors before your users encounter them. Thanks for sponsoring today's show, Sentry.
Welcome back to the show, everybody. Today I'm rolling solo. Kaushik's not with us, unfortunately. He'll be back with us soon. But we do have a great guest today, and really excited to talk to this guest today about a topic that a lot of people have a lot of interest in, but unfortunately, nobody really knows how to kind of get started with it. And so it seems kind of one of those things that's super interesting, but kind of has a big barrier to entry. Mainly, it could be perhaps just not knowing the right tools or the right way to get started. And hopefully by the end of the show, we'll be able to conquer all of those concerns that you have. So today I'm going to be talking with Dan Jarvis about Android and machine learning and all those good things. So without further ado, welcome to the show, Dan.
Thanks a lot, Don. Happy to be here.
Dan, for the folks that don't know who you are, maybe where you work, your background and so forth, could you give us a little bit of information, history about yourself, about maybe how you got into Android, machine learning, where you work, all that kind of good stuff?
Yeah, sounds great. So I've been a professional programmer for more than 15 years. The first 5 years was all back-end stuff, mostly like Java, JSP. And then I saw mobile phones getting smart and I got really excited by it. And then I just shifted into it. So initially BlackBerry and iOS, and then more recently, gradually specialized in Android. So I've got about 10 years plus of mobile programming experience. At the moment, I work at Capital One. I've been there about 4 years. I lead a couple of Android teams building internal SDKs that we deliver into the main Capital One app.
Excellent. So you and I met over at Android Dev Summit last year, 6 months ago, probably right on there.
Yeah.
And we got to talking, and one of the things that you had said that you had kind of had some background in was machine learning. And I found that really interesting because all the stuff that was talked about at I.O., last year regarding machine learning and TensorFlow and TensorFlow Lite and, ML Kit and all these crazy things that I still don't have much information on or background in, you had some experience in. And we kind of just sat there and just started chit-chatting about it, about basically all these different topics. And one of the things I asked was, what really is machine learning? How can I use it? Is it applicable to me as an Android developer? Do I need to have a PhD or anything like that? And so wanted to talk to you and get you on the show to see if you kind of break some of this information down for us. So I think the first question is really, is it really possible to do machine learning on Android, and what is machine learning?
Yeah, definitely. You can do it. To start with, what is machine learning? At the simplest level, it's really like showing a computer what you want to happen instead of programming it. So, imagine you were building something like an image classifier and you were trying to make your code detect when there was an Android robot. Like, you would write rules like find this color green and detect some shapes and things like that. And it would get really complicated. So you would have all these if conditions and things like that. With machine learning, you basically give it examples of the outcomes you want, which is usually data, and the system will just like learn how to give you the outcome. So you give it loads of pictures of green robots and loads of pictures of other stuff that's not green robots, and plug it in, and you would end up with a model that would be able to detect green robots for you.
So do you have to tell that I know we're kind of diving into the details a little bit, but do you have to tell the machine that this is a green robot and this is a red tomato, or do you have to tell it that, or is it supposed to learn that on its own?
Yeah, essentially, so let's break it down. So the overall process is you collect data, you prepare it so that it's in a nice format that the computer can read, you train your model, and then you deploy your model. So a model is just a thing that takes in some inputs, runs some logic, and returns an output. So it's just a black box. Once it's trained, you use it to get stuff. So for an image classifier, that black box model would take an image as input and it would output a label. So the way that you would train that is you would have loads of images with labels and just run it on a machine that will learn how to figure out which image is the which. So this is getting all into training, which I would say a big message is don't need to worry about training. For most of us as Android developers, we, for example, when we're doing REST calls, we don't write detailed HTTP requests and MIME headers and all these things. Like we don't do that. We just use a library that helps us send a request. And so I would say for most Android developers, what you want to think about is machine learning has models, but you don't really need to be in the business of building and training those models. It's more likely that you'd use a system that provides you with those kind of tools automatically, or you would have a team that delivers your model. So it's really important to understand what things can machine learning do for you and how can you use it in your app. And training, super interesting, but for most of us, don't let that block you from trying to get interested.
So I guess in other words, like I don't need a PhD in math to figure this out. I can still use it if I don't have a PhD in math.
Exactly. Like, do you know how to do all the different like SYN-ACK flows in TCP? Probably not. Like I don't. Yeah. But you can still do REST requests, right? So I think it's good to compartmentalize the bits that we want to use as tools from the training that we might want to do if we're trying to do something really clever.
So how did you get into machine learning? What got you interested in it?
It's weird. I was thinking about this the other day, and I did back when I was at college in 2002. I did like a dissertation on genetic algorithms. So a genetic algorithm is like using nature's mechanism to make your code better. So it was a tic-tac-toe game where it just like randomly generated different strategies, and you play them against each other, and the ones that win survive. That's what a genetic algorithm is. And that was really interesting to me at the time. I'm pretty sure I did a horrible job, but it was it was like a really simple form of AI. But yeah, I've always been interested in it. I like reading sci-fi. I listen to a lot of podcasts, so machine learning and AI is a big deal on that. And then in 2016, I went to DevFest DC, and they did some great demos of their new APIs they had produced. And I saw another open source project about neural style. Which if you've seen Prisma or Instagram, Facebook, those kind of filters that you can do where you take a photo and it makes it look like a Van Gogh or something, it's just incredible how it works. Like you can have a machine learning type system figure out what styles means for like a Van Gogh and apply that to any image. And I can put some links in the show notes, but the it's just amazing. Like to see it just blew my mind.
So so like I'm just gonna kind of go off to the weeds here, but like Instagram or Snapchat or whatever have those type of filters. So that's basically what they're doing, is they're using kind of this machine learning or whatever these algorithms to kind of apply these filters to do that. Is that what you're saying?
Yeah, I don't actually know how they build those ones. I believe it's done by taking a bunch of example images, and the technology that's behind a lot of the image classification work, it's effectively doing things like extracting those features from images automatically. So you can there's just a general principle here where if somebody's done some really big training for you, you can sometimes reuse that training in a simple way. So the best example I can think of is image classification, where when Google do their whole thing to train their image classifier, they're using 12 million images, 20,000 labels, God knows how long it runs for. But they've done all that hard work, and as a result of that, they have a machine learning model that actually has learned to detect like edges in images, textures, shapes, and then has different layers that gradually understand that putting two eyes and a nose and a mouth together is a face, and that stuff just like gets learned for you. And so you can take that incredible model and then you can just retrain it on a few examples. So now, you can do hundreds or a couple of thousand photos of something, and you have repurposed that giant piece of learning in a really simple way. So this is another example of how the training can be really big and complicated, but using it, what they call inference, is not that hard. And retraining is relatively easy if you just find a few examples online and you just follow some command line scripts to run, and then you're good.
Okay. Now, before we kind of hop into some of the details regarding kind of the ML Kit and all that kind of stuff, I think it's important to note that we are recording this actually right before I/O, so there is a chance that some of the things that we talk about today could change. Hopefully they don't, but there is a chance that they could change, be moved, or anything of that nature. But hopefully a lot of these theories and concepts and practices will still apply after I/O when this show has dropped.
Yeah, I hope so too.
So one of the other things that I know that we talked about before and I wanted to bring up again was that it seems like, if you're anyone who's on LinkedIn, everybody gets recruiter requests. And one of the things that you see all the time is like, hey, blockchain this, and, machine learning this, and AI that. And it just seems like everything is all like this hype all the time. And a lot of times after you see it so many times, you're just like, oh, that's just this hype. I'm not going to worry about that. I'm just going to focus on my own thing. Is machine learning kind of just like this hype, or is it just this specialized field that nobody should care about, or what?
I think it's a combination, obviously. So I would say there's elements that are hyped, but as a tool, it's here. It's really getting there. Most new technologies, they enter this like stage at the beginning where everyone's really excited about it, but it isn't quite there yet. But what we're seeing now is it's in its kind of adoption phase where it's coming pretty mainstream. So lots of companies out there are using it somewhere, right? Like machine learning, I think you struggle to find any modern company that doesn't have data scientists, and basically every tech company has lots of machine learning people too. And if you look, the trend is that this machine learning is kind of moving closer to the client. So Google's a real pioneer of this. So Google speech to text, like if you've looked on your Android phone and go into keyboards and inputs, you can see that it actually saves an offline version of Google speech to text. And I checked a couple of days ago and it was 47 megabytes on my phone, which is pretty incredible that you have a really awesome speech to text engine that works completely offline. Google Assistant, they recently moved to use all this new TensorFlow Lite stuff, so they migrated across to that. This isn't client side, but the one, Google Photos is one that for the last few years, the search is just amazing. You go in and you type like red hat or pizza, and it will just immediately return all the photos you've ever taken with those things in, which is just scarily impressive. But there's other companies other than Google as well. So I think one of them that was in the TensorFlow Dev Summit videos was Youdao, which is a Chinese company that has Chinese and Hindi dictionaries that are the most popular dictionaries in their countries. And there's even this really funny example of a Japanese cucumber farmer who builds an image classifier to automatically sort the cucumbers into the right buckets based on how they look, that was from 2016. So that's it's pretty crazy to see the things you can build.
That's pretty cool. I mean, those are real life, solutions to problems that people have out there. I mean, that's just automating. It's just what programmers do, That's fascinating stuff. So let's kind of go to the next step here. The majority of the folks that listen to the show are Android developers, of course. And the folks that are getting into this are probably kind of wondering, like, okay, machine learning sounds cool. It sounds like it can do all kinds of things. But every example we've ever been really shown is kind of been like, hey, here's a picture, we can find a face. Here's, we can find a hot dog, or whatever. And it always seems to be around pictures. For an Android developer, what do they need to know about machine learning? And mainly, my question is, like, what kind of problems can be solved with machine learning, maybe other than, trying to find faces in a picture? Yeah,
it's a great question. So there's a famous guy called Andrew Ng who is a big machine learning expert, and I think he launched the first massively online learning course around machine learning through Stanford, I think. So he's a big player, and he's got a great video called AI is the New Electricity, and he has like a bunch of papers he's published on it that are very accessible. But I'll give you it for the show notes. But he has this heuristic that to help you remember quickly guess what kind of problems it could solve. So anything that a typical human can do with at most 1 second of thought, we can probably now or soon automate with AI. So that's what he advises his product owners as like a quick way of thinking about it. If you were interested, I can take you like a little bit lower down into detail of how. So that's kind of quite focused on things like supervised learning. There are really 3 different kinds of machine learning. Supervised learning means that you have a bunch of labeled data, and usually that means humans have done it. Unsupervised learning means that you don't actually need to label the data. This is really amazing because the system can kind of figure it out itself. So grouping similar things is an example, so clustering. And the common example of that would be a recommendation engine. So, movies or products. You don't need to know anything about those products or movies. People who like A and B also like C. Like the system can kind of figure that out. And then the third kind of learning is reinforcement learning. And that means that anything that has a reward function, you can program in. So a great example of that is computer games. They have a score or how long you last before you die. And so like Flappy Birds, your reward function is how long do you stay alive? Or if you're playing Space Invaders, what's your score? And if you feed in the video frames for that, the evaluation is basically the system guesses different things it can do, and based on the score, it learns and reinforces itself. So you had supervised learning, which is labeled data, unsupervised learning, which is just data, and then you have reinforcement learning, which is rewards. So as a person who's like building systems that can benefit from machine learning, you kind of want to figure out which of those applies to you. And in most cases, almost all of the progress being made today is with supervised learning. There are some exceptions, but supervised learning is the most common one. And so the big advice I would have to people is think about systems that you're building and try and make sure you're capturing the right data. So to give you an example, we had a feature in one of our apps where we were offering coupons to users. And so for every coupon, we pushed and said, look, let's make sure we ask them, was it useful or not? Like, yes, no. And you see Google doing this everywhere, like every app is doing this. And that's because you're creating a feedback loop. And when you create that feedback loop, you're creating a way that the humans can train the system. So I'd encourage you, for every product that you build, think about how do I create those feedback loops and those, what I would call a labeling pipeline. And so once you've done that, you can then just give that data to somebody to maybe even just do like a one-off piece of training and then give you a useful model. So yeah, just to reel off a few examples, you talked about image classifiers. That's a pet hate of mine as well. Almost all the examples are visual. And I think it's just because they make for fun demos. But yeah, I'd say the other examples are spam detectors, sentiment analyzers. So is this text like happy or sad or angry? AIs that play board games as well as video games, handwriting recognition, optical character recognition, face detectors. house price estimators, like pretty much anything where you have some inputs and you have example outputs that you should get. Like you can train a model to give you some estimates or to predict things or to label things.
So technically, I mean, for example, I'm thinking, I know a lot of people that are in real estate, I guess you could probably train a model to say, hey, if I want to sell my house, usually when you price your house, it's kind of based off of the comps in your area is what they do. I guess you could probably train a model off that, some inputs from there, saying based upon the last, 100 houses that sold within a 5-mile radius of the same size. Here's the price. It had similar features. So here's what we recommend you could sell your house given this in this range.
Yeah,
here's
and I mean,
price. All
the big real estate companies like Redfin, Zillow, etc. I'm sure they're already doing this. You can see they have their own kind of proprietary estimates. Yep. So you probably wouldn't want to go compete with that, but it's a good example of the kind of thing you could train. So I think they do the typical version of that would be you identify all the features. So for a house, that would be the square footage, number of bedrooms, bathrooms, zip code, average sale price. So you put like 20, 30, 40 different things. You capture all that information and then you train it based on the prices that they actually sold for. And then the system is going to figure out which of those inputs is most important. So yeah, you can think of not just real estate, but pretty much anything where you can have a set of inputs like that and train it. An example that I've had in my head for years is trying to predict the right time to go leave to get your train. So, your phone knows where you are, and it knows when you've left your house, and it knows that how many minutes until the next train when you left your house. And then when you get to the platform, it knows you're there, so it can figure out how long you were waiting. So you could imagine an app that kind of figured out the right time for you to leave and gives you like green or red because it knows that if you left now, you just perfectly missed the train. So that's an example. If you were going to try and do kind of on-device training or, specific training for a specific user, you could get into that. But again, I just want to repeat the point. Training is not easy, and I would definitely start with something simple. I would start by installing, so TensorFlow has these demo apps, and you can install 4 of those just direct as APKs, and it will give you examples of object detection, image recognition, hot word detection, I think, a few things like that. So there's a lot of really cool examples. You can just download and install them, and the most important thing is that people understand the kind of problems that you can solve. So you can then talk to your product team and figure out the kind of stuff you can build. And you probably don't want to jump straight into training, certainly not anything novel. I would start by following some, tutorials. There's a really good one from Google for image classification called TensorFlow for Poets. And I did a version of that where I followed it and I was doing training on legs or hot dogs, that, that silly like internet meme thing. And that was quite fun to try out. So I'd start simple, definitely.
Excellent. So that kind of gives a good segue into building stuff as an Android developer. If I wanted to start building something as an Android developer, which a lot of the folks here on the show are probably wondering, like, okay, all this sounds cool. How do I get started? Do I need to go up on to a TensorFlow website and I need to read a bunch of documentation there? Do I follow a tutorial, or kind of what's the best way to do this? And maybe I want to build, let's say it's something like you said before, like I have a bunch of inputs for whatever reason. Let's say it's just real estate, and I wanted to build some little price estimator based upon these inputs. If I wanted to do that, what's kind of where would I start to get started with this? And are there different libraries or different tools I need to get going with? And let's kind of hop into there.
Sounds good. Yeah, I'd probably suggest like a set of stepping stones. So the first one would be install some demo apps that already exist and play with them. The next one would probably be play with some APIs. So, take something where you're just calling an API that does it all for you. So Google offer, I think it's like 7 different or more APIs now. Microsoft, Amazon, IBM, a lot of these big players have AI APIs that do a lot of these little machine learning type features. They're already pre-trained. You give it an image, it gives you labels back, that kind of thing. So that's definitely a good starting point. You can then also talk about whether you want to do that stuff in the cloud or locally. So we can talk more about ML Kit later, but ML Kit is Google's way of exposing those APIs, and you can choose to do the on-device versions or the cloud-based versions. And so, why would you pick one or the other?
Yeah, let's hop into that. Yeah.
Yeah. So the advantage of doing it on device is it's lower latency, it's more privacy, right? Like that your data never leaves your device, and it's cheaper because it's running on the device using the processing power of the device. It doesn't need a whole back-end system. And most of the Google APIs, when you run them in on-device mode, they're free to use. Why would you use cloud-based? Well, it's generally better, right? It's going to have more sophisticated stuff, bigger machines crunching it, more data. It's also, if this was something where it was like the secret sauce for your business, you probably wouldn't want to deliver the model to the device, right? Yeah. Because somebody could pull it off the device and use it. So if there's some real proprietary stuff in there, you would definitely want to keep it on the back end. And a lot of the time, it might make sense for it to be in the cloud. Like there's probably other things that need to happen in addition to that model, and perhaps the model's really big. Like it might not be one that optimizes that well. So yeah, the trade-off is mostly those things.
Let me ask you this quick question too. For the folks that are listening, they're probably wondering if they've never even dove into machine learning, but they've probably heard from Google the words TensorFlow. They've heard ML Kit. They've heard TensorFlow Lite. Can you tell us about what is like TensorFlow for someone who's never heard it? What does it do? Why do I care about it? Like, how does that compare to TensorFlow Lite? And then kind of how does it compare to ML Kit? There's these three things. I'm not sure what they are. How do they work kind of together from like a beginner standpoint?
Cool. Yeah. So TensorFlow is just a general machine learning library. It's completely open source. It has like a bazillion stars on GitHub. It's an incredibly big project. It was written originally by, I think, Google Brain, and then they open sourced it back in 2015. So it's just general purpose machine learning. It's not really built for mobile. It's more built for kind of machine learning people in general, right? So it was great. You could get it to work on device, but the models were really big and there was quite a lot of manual steps and a lot of things you had to do with your build that were kind of painful. So it was great, very powerful, but not ready for mobile. In May 2017, they launched TensorFlow Lite. TensorFlow Lite is optimized for mobile. So all the different stuff that happens inside those models is like optimized for mobile. The runtime environment, instead of being like many megabytes, they got it down to a few hundred kilobytes, so you could deliver to the device. They changed the file formats of the models. In TensorFlow, the models were all protocol buffers, which is a really cool technology in itself, but they've gone even further for TensorFlow Lite and moved it to flat buffers, which is even more optimized for performance. So basically, TensorFlow Lite is this targeting of TensorFlow for mobile, making it smaller, faster, and just ready for mobile. It also adds in things like supporting microcontrollers and Android things and things like that. So I should say as well, it supports iOS, which is really awesome. So it works on Android, iOS, Android things, and even microcontrollers.
And that's TensorFlow Lite, does that?
Yeah.
Oh, wow.
I suspect in all of these cases, everything does work from TensorFlow as well, I would think. I'm not totally sure, but you probably wouldn't want to try it.
It's a little too big.
Yeah. And then the next evolution, which was a year later, so middle of 2018, ML Kit came along. And ML Kit uses pretty much the same stuff that's in TensorFlow Lite, but it shrink wraps it all and makes it available through all the Firebase APIs. So if you are into the Firebase ecosystem, then ML Kit's a really good choice. It just helps you configure it. There's nicer APIs. What else? I guess if you're not into Firebase, the one downside would be, you need to configure the app to communicate with Firebase and all that. So you get a lot of benefits from the rest of the ecosystem. So say you want to A/B test two different models, for example. ML Kit will let you do that using Firebase. You can upload your models to Firebase. You can have an A/B test in Firebase, which is configured using all their remote config stuff, and that will hook together quite nicely with ML Kit. So you get more shrink wrap features with ML Kit, but I don't think fundamentally it's really any different to TensorFlow Lite.
So with I hear you say Firebase here. So does that mean? And you mentioned something earlier about on-device privacy, security, all that kind of stuff. And then you said Firebase uploading a model. So I'm kind of wondering what the difference is here. If I'm using ML Kit, then I have to use Firebase. Does that mean I have to upload things to the cloud? Or and is TensorFlow Lite only local, or kind of what's the difference there?
Good question. So ML Kit supports both. When you're configuring it, you can say whether you want to do the local on-device version or the cloud version. And some of the services will actually vary based on which you pick. Some of them are only available in one or the other. Most of the services are actually only available locally. I actually got a chart somewhere here. Two services are offered in both places. So image labeling, for example, you can do the on-device version or the cloud version. If you do on-device and say they have an example with a photo of a soccer stadium, the on-device one will just say like sports and stadium, but the cloud-based one will have more detail like soccer team and things like that. So more rich labels, but obviously you have the extra latency of going to the cloud. And in this case, the cloud one does cost some money, whereas the on-device one is free.
Okay. So
some of them offer both. Going back to the original question.
So it's only if I say, hey, Firebase, I want you to run this on the cloud, then at that point it goes to cloud. Otherwise I can tell, hey, just go to the device. And now let's talk about that on-device stuff, because I think that's the real, the interesting thing here is for the on-device stuff, what are the features that are available on device? Do you know?
Yeah. They have a really good chart which we can put in the show notes. But so there's 8 features, and everything except the landmark recognition works on device. So landmark recognition is kind of part of the image labeling. If you have the Eiffel Tower in a photo, it will say, "Oh, I found the Eiffel Tower," and it will point you to the place on the Google Knowledge Graph that will tell you more about that thing. So text recognition, face detection, barcode scanning, image labeling, language identification, smart reply, and custom model inference are all available on device. And then the only 3 of them are on the cloud: text recognition, image labeling, and landmark recognition.
So you can do quite a few things. I mean, with this, text recognition, that can be very useful, especially if you're building some type of camera app to do something. You can do that all on the device. Language, smart reply. Okay. So the one I think that might apply to a lot of folks here if they want to build their own custom app is the custom model inference. Is that where you can kind of build your own custom model?
Yeah. For a custom model just means that, say your machine learning team have built your model, you can convert it to a TensorFlow Lite model and then deliver it down into ML Kit. So you can either bundle it in the app, or you can also, or instead, put it in Firebase and have Firebase serve it down to the app for you. You also don't have to do that. Like if you want, you can roll your own, of course. Like it's just delivering a file down, and then when you're going to run the, as they call it, the inference, like pass your inputs on the device to the model and get the result, you can do that all yourself. But if you want to use Firebase, they'll help you manage that. If you want to do it yourself, you can use TensorFlow Lite and just do your own distribution down to the app.
Okay, so we got ML Kit. Seems like the place where we should probably be starting, is it seems like it gives us all of the hooks and everything we kind of need to start building an app. And if I wanted to start building an app today using TensorFlow and machine learning and stuff like that, what would be the steps that I would need to follow to kind of start building an application?
You basically set up your app for Firebase, import ML Kit, and then follow the tutorial to add 10 or 20 lines of code with all the configurations you like. Saying when maybe you're using the pre-built stuff and you're just going to say do all the on-device examples, or maybe you want to take a photo and send it to the cloud. You can say, hey, I want to use the cloud-based version, and then you have all your callback hooks to say what to do with the result. And they have, as you'd expect, they have a quick start Android app, so you can go grab that. Again, we can put it in the show notes. It's GitHub, Firebase, quick start Android, and it's pretty quick. You have to create your own Firebase account, which is all free, and then provision your app in your Firebase account. So you basically take the package name of the app, drop it in Firebase, into your Firebase account, and it gives you this, I think it's called like a google.services file that you download into the build, and then you can run it. So they just need to basically know that your app is connected to some Firebase account. So there's this one step where you kind of register your version of the app to your Firebase account, and then you can run the demo apps.
Okay. So let's take this like a different, let's use an example that you were kind of talking about earlier. Let's say that at your company, you've built perhaps you provide reviews, whatever, you're a review company, and you provide a white labeling review site or whatever, and you provide them with a up or down like button. Say, do you like this comment or not? And then that's, the machine kind of learns how it should sort or say related comments or something. If I wanted to do that, of course, maybe my application is built in Python or Rails or whatever, and that's where all that data is at. If I want to get that data into machine learning and eventually get that into perhaps my application or anything like that, or perhaps I have an API I need to communicate that with, and again, this is beyond the scope of an Android app. How would I set that up? Would I have to have TensorFlow in the cloud built myself? Should I communicate with Firebase? Do I have to have my backend servers communicate with TensorFlow, or is there like a general format that folks follow when they kind of have an existing system they want to start, having data trained off of?
Yeah. So today, most training works as like a big bang batch process. There are not many training algorithms that would allow you to kind of incrementally adapt your model. Like as you receive individual lines, adjust things. That's not something I'm aware of as being like mainstream. So I'm sure we'll get there. But so the way it would work today is you just need to make sure that your data mountain is available to your analysts, right? So most people would end up saving to like log files or a database or something. And it doesn't really matter where you put it, as long as you can make it easy for a machine learning person to pull that data in. So make sure that it's structured clearly, and you can give them a really good schema for that data. So I'm trying to think, our analytics end up going into some like back-end database system, and we just need to be able to give people ways of querying it to pull out the data. And then you go to the machine learning people and say, hey, here's all my data, here's what I'm trying to achieve. What we do at Capital One is we have a center for machine learning, who are all these kind of experts who work with academics and do research, and they're doing a lot of detailed stuff around explainability and things like that. But the interesting thing is we can pull them in and say, hey, can you consult with our team, help us with this project? And they will help get us on the right track and show us how to build the models. And then as Android engineers, we can say, oh, I want you to do the training in TensorFlow because I really want to get the models to the device. So I'm kind of skipping over it there, but the key thing is you need to figure out, where does your model need to live? So usually, if the model's going to live at the back end, you don't care how they train it, right? Like it's just an API, it's just a service. But if you find a use case where that model needs to come to the client, now you're starting to have to impose your will on that team and say, look, I need you to use a tool chain that you can deliver the model to the client. So if you need to get the model down to Android or iOS, then you may want to start saying, hey, I think you probably want to use TensorFlow because there's good ways of delivering it down to the client.
Is there any examples you know of, like where, because it sounds like, let me rewind. It sounds like a lot of folks out there who are in startups, big companies, whatever, are going to have the data already. They're maybe going to, like you said, they have a team of folks, or maybe they're hiring a team, and they're going to be able to create that model somewhere. And again, I think it's important to note and recover something that you said, that is, if your bread and butter of your company, your, intellectual property is part of that model or whatever, you might want to keep that on the cloud. You don't want to bring that down to the device. Is that correct? Is that what you said?
Yeah,
something
absolutely.
Like
it depends. I would describe it as being like, is it your special source? Like if it's, let's try and give an example. So one of the things my team does is we do like driver's license capture as part of identity verification. Yeah. And so you wouldn't want your model to have all your detailed fraud checking rules to be down in the client, right?
True.
But you detecting that there's a rectangle just for the purposes of when to capture the photo, that would be something that you probably wouldn't consider that super proprietary. So you'd be happy to have that come down to the client. So that might be one example of where you see the split, where something that's sensitive should be on the back end, something that's going to improve the user experience, and probably isn't going to be that big a model either. That is something that you could probably put it down in the client.
So that's a good example, actually. Let's say like you're detecting a driver's license. You know that there's going to be a rectangle somewhere of a photo. There's probably going to be some text in a certain style format. And as long as that image that you're scanning kind of adheres to those general principles, you can say, hey, it looks like this is probably a driver's license. Cool, let's take a picture of it now and send it up to the cloud and let the backend systems really determine and run the fraud checks there. But at least it allows you to then check locally, hey, is this actually a driver's license or not, and save that time. Would be a correct assessment? Or
yeah, that's exactly the sort of thing that you could do and would demonstrate the difference between parts that could be on device versus on the cloud. Now, if your backend team are like not into TensorFlow and there's no easy way for you to train that model, then maybe you find a different way of capturing the images.
Interesting. Okay. So that kind of brings us to a good question of, we know we have stuff in the backend server that could be, and maybe has a model that's built by a particular team or scientist or whatever, and maybe we've delivered that down. Do you have any kind of other heuristics to say, hey, here's some stuff that you could do on Android, or here's some of the things that you should probably consider using ML Kit for on Android for developers that are listening?
Not really. We listed the 8 kind of categories of things that ML Kit can do. I think that the custom model one I think is really interesting, because what you can do there is follow examples online and just deliver those models down into the ML Kit. So ML Kit is just a mechanism for calling Google's APIs or injecting custom models, and it just makes it a little bit easier for you to integrate. I would encourage people to find examples that interest them online. Mm-hmm. The most common ones are image classifiers, spam detectors. What was the other one I was thinking of? Handwriting digit recognition, right? So there's this data set that's hilariously like 20 years old and was first distributed on CD, and it's still used for all the training examples. It's called MNIST, MNIST, and it's a bunch of people's handwritten digits, and people use that all the time to do example training on. And so like there's an open source project that I contributed to a couple of years ago. They had a TensorFlow example, and I helped move it to TensorFlow Lite, the version of TensorFlow just before TensorFlow Lite. So pretty easy to do. You just download the project, you can run it, and you can find those kinds of examples. That has a training script attached to it to show you how to just run some simple training for a handwriting recognizer. And it should be relatively easy to take something like that and just create a TensorFlow Lite model from it. You would take the model that was built, run it through the converter, and you should be able to drop it in an app. So I would encourage people to find examples that are similar to something they want to do and just play around with them.
One of the things that I've noticed over the years of being a developer, and you've probably seen this as well, is someone will have an idea, say, hey, I know I can use machine learning to figure this out. And the idea is so grandiose that it would take forever to implement. And we're all guilty of this from time to time. Like, I want to do X, Y, and Z and build this awesome thing. But if I want to get started in ML Kit, is there perhaps an example of of something I could do? And maybe it's even a tutorial or something that you've done to say, hey, the simplest example to kind of get your feet wet with the whole platform, and of course the demo apps, but if I want to build something, what should I build? Should I build perhaps something with the text recognition stuff? Would you recommend the face detection, landmark identification, smart reply, or something like that? What would you do? Because I assume that the custom model stuff is going to kind of be like step 2, 3, 4 instead of step 1. What would be the first place where you'd say, hey, here's where you kind of want to get your feet wet with the ML Kit stuff?
I mean, custom models would mean that you have done the training, but you don't have to be the person that does that training, right? Like, you can go grab one of those pre-trained models from... Yeah, so I think the order I would say is install demo apps and play with them. Then I would say use some simple APIs, whether it be Firebase or one of the other big players like Amazon, Microsoft, whoever. And then at that point, you've done some machine learning services. Now you're getting into the business of saying, like, let's level up and start to use an embedded model. So grab some pre-trained models from somewhere and try dropping those in. Maybe like take one of the demo apps and just crowbar some other pre-trained model that you got from somewhere else into the demo app. great.
Okay.
I would probably say that stick with image classification, because that's the one where there's just so many examples of it online. You'll probably find it easiest. And then the final step would be to do training, and start with something really similar and just follow their script for training and just adjust it a little bit. And the one you see almost everybody do is retraining an image classifier. It's pretty easy to do. You can basically just go to Google Images, search for the new thing that you want to train it on, grab loads of those images. Another cool way of doing it, which I've seen people do, is they record a video of the thing they want to recognize from loads of angles, and they use like FFmpeg or one of those tools to split it into frames and use those frames as training data, because you can generate thousands and thousands of examples real quickly from a video. I'll put a link in there for FFmpeg for folks who aren't familiar with it. It's actually a tool I use quite a bit. So that brings up a good question. You mentioned pre-trained models. Is there a place that I can go to where I can just go find some pre-trained models? Oh, that's a good question.
Or does Google provide any out of the box that they allow you to download?
So in the TensorFlow project, they have a whole load of models up there in GitHub, but I haven't attempted to try and go through them all. The main ones that come to mind for the image classification are you have Inception, which was like I may have got this wrong, but I think it was the first model that started to beat humans for classification accuracy. And then Inception v3, and there's all these different versions. And then there's something called, I think, MobileNet, which is the mobile optimized version of that tends to be a lot smaller and is different in some way. So I actually don't know a good place to get them. I tend to, you'll find a bunch of them in the sample apps. So like if you install the ML Kit sample app, I'm pretty sure in there's 3 different versions of some of the models. But yeah, if you're doing something like that, you should be able to find some just by following tutorials.
Okay, cool.
I think ML Kit will mostly try and hide it from you, right? Like if you're doing the on-device versions of ML Kit, you won't even know that it's doing things. Like Smart Reply is quite an interesting one. It's part of ML Kit, and it will use the last 10 messages in a chat thread to help figure out what auto reply to use. So like when you're in Gmail and it offers you a smart reply, just thanks, that's interesting, or whatever. There's a on-device version of that you can use for like SMS threads and things like that, where it's actually looking at the last 10 messages in your history and feeding that into an on-device model to recommend a possible reply. So I'm guessing it's figuring out things like, did you ask a question? And if it figures out that a question was asked, maybe it would say like, yes, no, maybe.
Okay.
Right. So I don't even know how it's working, but it's kind of interesting.
Okay. So you mentioned something earlier too. We've kind of skirted around it, but it was some of the more advanced stuff that we originally wanted to talk about. And that was, how do you actually train like a machine learning system? And you said it was kind of just, taking the existing files, like some pictures or the FFmpeg thing, and kind of just passing those over. But how do you do some more, that's for an image classifier. How would you do something more custom? And what does that look like from an advanced level?
Okay. So I could talk a little bit about something I was doing on a side project, which was like trying to classify documents. I wish there were more examples for text, because they're all very image based, but it seems like quite a common thing you'd want to do is automatically detect what type of document something is, right? Like imagine there are hundreds of different forms you expect to receive and you want to know which one you just received. So I was trying 2 different approaches. Initially I was trying to build a neural network to just figure out which forms are which. So giving a bucket, like just all the text coming in as input, and then training it with supervised training. So say like I've got 1,000 forms and here are the different types they have, and I want the neural network to just figure it out. The problem with a lot of the training examples is if you go too far away from any existing example, now you have to define the neural network. And that's the bit where whenever I go to a meetup group or something, like I'm with it for most of the way through, and then they just say like, now configure a neural network with 3 hidden layers and 25 connections, like boom, I'm just dropped off a cliff and I'm lost. So I don't recommend attempting to figure that out because it's crazy hard. But I was trying to do a version of that, and I struggled. And the problem is, if you're trying to build a new model from scratch, you tend to need a lot more data than retraining a model. That's what I was saying earlier. So I kind of struggled to get that to work. So I then fell back to just basic data science, where there's this thing called topic modeling, where you can come in and it's a very well-established technique where it compares documents and it tries to find the bits that are unique between documents. So let's say like some of the forms have one word in a lot, but there's like this individual phrase that's only in each of the documents. Like that's going to get special importance. It's not going to add much importance to the word the or the because it's in all the documents, but any unique phrases between them will allow them to be differentiated. And now that you have this, you basically use like a similarity matcher. So when you see a new document, how similar are its topics to the 100 that you've seen? So so that was an example where like I was trying to solve it with cool machine learning stuff, and like it completely failed. And the way they got it to work was just like classic data science with topic modeling. So there's like a lesson in there. We just shouldn't stray too far from known examples because it's just really hard.
Yeah, that kind of makes sense. I mean, everything that I've seen with ML or AI or machine learning, and I've kind of looked at some of the online courses that are offered from universities, and just I would kind of start reading into them. There were free courses, and I dive into a couple of chapters, and I get into it. I was like, wow, okay, I need to go relearn some math or some theoretical stuff that I have no idea about. And it seems like once you kind of start getting into those levels of things, you've gone a little too deep.
Yeah, I think there's like a middle tier of education that's missing. At the moment, you have the people who want to use it, like us, and then you have people who want to train the models. And there's just something missing in the middle. Like, I don't want to be retraining neural nets, right? Like, just like I don't want to be writing raw TCP, handshakes and network data. Like, that makes no sense. But what I do want to know is I want to be able to look at a list of all the different models like you were suggesting and say like, oh, you know what? I want to do a document classifier. Where's a good model that I can start for that with? So maybe there is a library somewhere of all these things, but what you want, it's like a kind of craftsman's guide to machine learning where you don't actually have to know how to build a model from scratch, but you need to know what's available and easy ways to customize them.
So when are you writing that book?
Yeah, maybe I'll take a 2-year sabbatical and do it.
Exactly. You also mentioned something interesting before the show regarding something about these, I don't know if folks have seen, there's some generated faces. Can you share more about that or what it was?
Oh, yeah, that's crazy stuff. So I think it was NVIDIA published this paper recently where they can now generate human faces that just look perfectly like faces, and you look at them, and so I think some people built websites where you had to pick which face is real, which face is fake, and probably about 2/3 of the time you just can't tell. At the moment, the system has a couple of little hacks where the model hasn't figured out that people's eye colors are usually the same, for example. But the way it works is it's called generative adversarial networks. And the way I think about it is like you create one model, right, which is a face detector. You now set up a second model, which kind of effectively just like generates faces until it can beat the first one. And now you like play off the two models against each other. And you have this arms race of one is trying to like detect faces and one of them is trying to fake them. And so the models that you used and you trained it on how to detect a face, you can then kind of use those in a way to train generating faces. So there's another thing here which is kind of crazy where we talked earlier about the style transfer where you can turn your photo into a Van Gogh.
Yeah.
Well, that's what you can do with faces as well. So you can have like a grid of different faces on one axis and different faces on the other, and you can gradually like morph each of the faces into all the others. So it's like taking the style of one face and applying it to another. So it can change like the hair, the skin tone, the eyes. We'll put it in the show notes, but when I've seen some of those, it really blows my mind. And it's really interesting as well because it applies in lots of ways. So imagine you have like you could use a machine learning model to try and beat antivirus detection, right? Like it's a perfect training example. Like the model was saying this is a virus, so the bad guy can generate the viruses until they can get past the antivirus detection. So you have, again, a classic arms race between the two models to detect viruses and models to beat them. So anyway, it's just like a whole class of interesting things where it's not just that you can use machine learning models to like detect stuff. You can use them to generate things. I saw this crazy example. I can't remember now. It was trained on music, like drummers, and then you could use it to just generate drumming, like out of nowhere. And I'll have to try and find it again. I think they showed it one, and it sounded amazing. Like it sounded like the best drum you've ever heard, and it was completely just generated by a machine learning model. I saw this guy who'd built a robot arm that would paint you stuff generated using styles. So just like the way you can apply neural styles to a photo, it would do it but mechanically with a robot arm and a brush.
Wow.
And you can then take that and generate new styles and tell it to do things like find me a style that's quite different from all the other styles you've ever seen. So it's a whole area of art and human innovation that you can drive based off of machine learning. So it's really fascinating. That's
interesting. Well, Dan, this has been quite the conversation with all things machine learning, ML, everything like that. Do you have any resources for folks that are listening that you might be willing to share? We can put in the show notes that you'd say, hey, these are some places you go check out and learn more. Yeah,
the ones that I use I subscribe to this newsletter called Inside AI. It's run by the guy who does the This Week in Startups podcast. Like their company's called Inside. So there's I just find that really good. It's a daily newsletter, but I tend to just read the weekly one. I think the daily one's a bit too much, but that will just tell you all the new stuff that's going on. Just one disclaimer: whenever you read headlines about AI and machine learning things, there's a big gap between the research headlines and what you can put in production. Like normally the research is quite sterile and has kind of contrived examples, so it's quite hard to productionize, but it will be good to show you the direction things are going.
Okay, that's a good tip.
And then the next one, I would say if you're looking for one starting point, I'd say the TensorFlow Dev Summit. They have a really good set of videos. If you're going to watch a single one, just watch the TensorFlow Lite videos, because the rest of the summit is more about general machine learning and very training focused. But TensorFlow Lite is really on the money. Like it's everything you need to know for mobile. So I'd highly recommend that.
Okay, cool. All right, so we'll put those links in the show notes. If folks are interested in getting a hold of you to ask you questions and so forth, what's the best way for them to get a hold of you?
LinkedIn's probably best. I don't really use Twitter much. So if you want to send me a message or connect or something, just go on LinkedIn and find me. As you'd expect, like everyone, we're hiring for everything. So Android, web devs, and we also have some interesting back-end API developer positions too. So if anyone's interested, get in touch. And I have like a Medium and a GitHub account. Both of those are DAJ is my handle on those.
Excellent. So we'll add links for your LinkedIn, the Medium, and GitHub accounts. And then folks, if you're interested in the various positions that are with Dan and his team, please reach out to him. You have anything else that you'd like to share, Dan?
No, it's been a real pleasure. Thanks for having me on.
Well, thanks for joining us today. We appreciate it. And we will see you in the next episode.
I want to thank Sentry for sponsoring today's show. Their tagline is, "Your code is broken, let's fix it together." They're a super cool crash reporting service that gives you all the helpful details that you need when detecting and fixing errors in your application. Don't wait for your users to report your errors and crashes. Use Sentry to catch them earlier. Check them out at sentry.io/for/Android. Once again, because Sentry is a common word, I want to make sure you get it right. Sentry.io. My thanks to Sentry for sponsoring today's show. That's it for the show, folks. Fragmented is hosted by Donn Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.